Welcome to another video in which I'm going to look at some examples involving sequences, which is a topic discovered in most college algebra courses. Let's begin by looking at the definition of a sequence. It states a sequence is a function whose domain is a subset of the set of positive integers. So normally you'll be given a formula, like in this example here, a sub n is equal to 2n plus 1. Or it could be in set form 2n plus 1. And the domain will usually be 1, 2, 3, 4, and so on, the set of positive integers. So to get the first term of the sequence, you would put a 1 there, and you'd get a 3. You put a 2, you get a 5. Put a 3, you get a 7. Put a 4, you get a 9, and so on. And you generate the terms of the sequence. Now, the only time that, say, 1 will not be in the domain is you have something in the denominator that will give you 0. For example, if you have n minus 1 in the denominator, you put a 1 there, you're going to get 0. So that would be undefined. We'll also look at summation notation. So right here I have the formula for summation. I equal 1 to n of f of I. So this means this expression right here will have some expression involving the variable I. And this will go from 1 to whatever this number is. Call it n. So you put a 1, you get the first term. You put a 2, you get the next one. 3, and so on. And then you add them up, and that gives you the sum of those terms. Okay, so let's look at some examples. The first one states write down the first 5 terms of the sequence. Okay, so that means we want to find out what we get if we put a 1 there. So put a 1 where the n is, and I get 1 there, and this gives me 10. So the first term here, you can see the answer is 1/10. You put a 2 where the n is, and both the numerator and the denominator, we get 2 over 11. You put a 3, you get 3 over 12, which reduces to 1/4 here. And then you put a 4, you get 4 there, 13 at the bottom, so it's 4 over 13. And then you put a 5, and a 5 here, you get 5 over 14. So that would be the first 5 terms. And then of course it keeps going on as many terms as you want. Now I'm also going to show you how to get these using the calculator. If you've got a few terms only, it's no big deal to just plug in the numbers and get them. But if you have a lot of terms, sometimes it's convenient to use the calculator. So I'll be using the TI-83 Plus. So here's what we're going to do. We're going to go to second and then stat. So second stat, I'm actually accessing the list menu. So second stat, and I'm going to have to reset my calculator here. Having some problems, so reset it. Let's try again. Second stat, and then have 3 menus here, so I'm going to go to the middle one. And number 5 is sequence, which is what I'm dealing with. So I'm going to hit 5. And for this one, I simply put the formula. So what's my formula right here? N over n plus 9. So it doesn't matter what variable you use. I'm just going to use x. So it's x divide by, and then put this in parentheses, x plus 9. Close parentheses, and then hit a comma, and then tell the calculator the variable you're using. So put an x there, comma, and then the range of the number. So you want the first 5 terms, so it's going to go from 1, comma, 5. And then hit enter. And I get some decimals. So again, if I want this in fractions, I go to the math menu. And the first one is fraction, so hit enter. And then this is going to convert the previous answers into fraction. So you get that. Yeah, so we get 1/10, 2 over 11, 1/4, and then we can scroll over here to see the rest of these. 1/4, 4 over 13, 5 over 14, and so on. So for the next one, we could do the same thing. We could do it manually, plug in a 1 there, put in a 1 there. So it'd be 3 to the first is 1, 4 to the 1 is 4 plus 1. So this would give me 3/5. And then we go to the next one. 3 to the second is 9. 4 to the second is 16, and 1 gives me 17. And I would get these numbers here if I keep on going. Okay. But let's do it in the calculator. So again, I'm going to second, stat, number 5, and then do it again. So enter this formula. 3 to the x, divide, parentheses now. And this will be 4 exponent of x plus 1, close parentheses, comma, and then x, tell the calculator the variable, and then the range again is from 1 to 5. So this is 1, comma, 5, close parentheses, hit enter. Again, I get decimals, so go to math, hit enter again, and we get 3/5, 9 over 17, 27 over 65, 81 over 257, 243 over 1025. You get these answers. And now this one again, you could, if you did it manually, you'd have -1, put a 1 there. That would be -1 to the first would be a negative. Put a 1 here and a 1 here. This is going to be 4 times 7 will give me 28, and I get -1 over 28. And then I do the same thing. Put a 2 there, -1 to the second is a +1. Put a 2 there and a 2 there. Okay, and that would give me 5 times the 8 gives me 40, and you can get them that way, or you can do it in the calculator. Okay, so either way you'll get this answer here. Okay, now let's look at the next example. Let's write the first 5 terms of the sequence defined by the recursive formula. Okay, so in the previous problem, you were given strictly one formula, a straightforward formula, non-recursive if you want, and you just plugged in 1, 2, 3, 4, and 5. In this case, it's a recursive formula. So in a recursive formula, you get the next term by performing certain operations on the previous terms. So for this one, this says A1. So this says the first term, that's what that means. The first term is equal to 1. And then it gives you a little formula to get the rest of the terms. So this one says A sub n is equal to 4 times A sub n minus 1. Okay. Now if you list the terms, A sub n would be the last term, and the term right before that would be A sub n minus 1. So all this formula is saying is to get the next term, you multiply the previous term by 4. Okay, so that means, okay, the first term they give you to be 4 here. So multiply 4, the first term is given to be 1 rather. So multiply 1 by 4 and you get the next term, which is 4. Okay, to get the next term, which would be the third term, you multiply the previous term by 4. 4 times 4, 16. Okay, fourth term, multiply the previous term, or the third term by 4, we get 64. For the fifth term, multiply the fourth term by 4, we get 256. Okay, that's what the way you do that one. Okay, look at B. The formula is given. So they tell you the first term is 2, and then it tells you that the nth term is given by A sub n minus 1 divided by n squared. Okay, so that means if you want the second term, that would be A2, and this then would be 2 squared here because you want the second term, and then 2 minus 1 would be 1. So this is saying to get the second term, then divide the previous term by 2 squared. So that would be then 1/2, or 2 rather, divided by 2 squared. So 2 divided by 2 squared is 2/4. Reduce it down and you get 1/2. Okay, now for the third term, you follow this formula. The third term then, according to this formula, is going to be the second term divided by the position of that term squared, which is the third term. So this would be 1/2 divided by 3 squared. So 1/2 divided by 9, if you compute that out, is 1/18. Okay, that's what you get. Okay, now again, follow the same pattern. For the fourth term, that would be the previous term, which is 1/18 divided by 4 squared. That's following this formula right here. Okay, so 1/18 divided by 4 squared, that would be 1/18 divided by 16. 4 squared is 16. Okay, so that comes out to 1/288. And then finally, for the fifth term, that's going to be the previous term. That's what the formula is saying, which is 1/288 divided by n. In this case, is 5. So you have 1/288 divided by 5 squared, which is 25. So 1/288 divided by 25. That's the same thing as 1/288, and the bottom you multiply by 25. That gives me 1/720, or 1/7200, I should say. Okay, so these really are not conducive to do it in the calculator. Now the next one, C, it tells you the first term. It tells you, okay, the first term is -4, and you want the first 5 terms. So according to this formula, if you want the nth term, that's going to equal to n, whatever n is, minus a sub n minus 1. Okay, so a sub n minus 1 is the previous term. So if you look at this, then if you want the first term is -4, so you want this term right here. Okay, so in this case, you want the second term, so n is 2. N is 2. So basically then it's saying the second term is 2 minus a -4. 2 minus a -4, that's 2 plus 4, which is 6. That's what we have. Okay, now if you want the third term, then according to this formula, that's going to be n is 3. So it'd be 3 minus the previous term. So this would be 3 minus 6. Okay. Which is -3. 3 minus 6 is -3. Okay, now if you want the fourth term, n is 4. So according to this, then it would be 4 minus a -3. 4 minus a -3 is the same thing as 4 plus 3, which is 7. Okay, now for the fifth term, n is 5 here. So all it is 5 minus the previous term, which is 7. So 5 minus 7 is -2. And that's the way you get this. Okay. Now, sometimes you're supposed to list the terms of a sequence. There's some problems where they're going to ask you to find the sum of the terms of a sequence, and sometimes they'll give it to you in summation notation. Okay, so for the last example, we're going to be looking at this summation formula right here. Okay, so you look at the first one. It says find the sum of the sequence. Okay, so if you do it manually, then this is k equal 1 instead of I. Over here it's k, so that's fine. It's just a variable. So this is k equal 1 to 20. K equal 1 to 20. So this means put a 1 where the variable is. Okay, there's no k here, so think of that as k to the 0. Think of that as k to the 0. So you put a 1 or a 2 or a 3 all the way up to 20. When you take those numbers to the 0 power, you're going to get 1. 1 times 3 is going to be 3. So basically all you're going to have for this first one, if you did it manually, it's going to be 23s, which is going to give you 60. Okay. So basically, if this number right here is a constant, that is, doesn't have a variable, and it goes from 1 to some number, in this case 20, it's just going to be that number times this number. Now, if you have a variable, okay, like in this one there, then you're going to have to plug in 1, okay, for that one. Put a 1 there. That's 4, 9 is 13. Then plug in a 2. That's 8 and 9, 17. Plug in a 3. That's 12 and 9 is 21. Plug in a 4. 4 times 4, 16. 9 is 25. Plug in a 5. 5 times 4 is 20. And 9, 29. So you have 13 plus 17 plus 21 plus 25 plus 29. And you get this answer right here, 1 over 5. And then you would do the same thing. If you're going to do it manually, you would do the same thing with these. Okay. But I like to, again, whenever possible, incorporate the calculator. So in this case, if we list out the terms for these formulas, we have basically sequences. That's what a sequence is. It's a list of terms or numbers in this case. So since we want to sum, here's what we're going to do. It's going to be second stat, and this time I'm going to go to the math menu, and number 5 here, see, is sum. Hit enter. Oops, wrong one. So let me clear this. Second stat. I got to hit the 5, so I want 5 because I want the sum. Okay, so there it is. So I want the sum. So what I want the sum of the terms of a sequence. Okay, so then I go back again to that same menu, operations, and I access the 5 again, except this time it's sequence. So this is telling me, see, this is sum here, and this is a sequence here. So this is taking the sum of the terms of the sequence. So it's adding those terms up. Okay, so this one has the formula 4k plus 9, so I'm going to enter 4x plus 9. Okay, and then I'm going to say comma, and then enter the variable x, and then comma, and then I want the range from 1 to 5. So 1, comma, 5. Close parentheses, hit enter, and I get 105. Okay, so that's what we got a while ago. See, this is convenient. In this case, the numbers are not that large. We only go from 1 to 5, but what if you had from 1 to 100 or 1 to 200? That would be kind of tedious to list all those terms and then add them up. See, so it works out nice for this one. Let's do the next one. So I'm going to clear this. Second stat, 5 is sum. I didn't use my sequence, so I need the sequence here. So second stat operations. Okay, 5. Okay, so I left that out. So I need the sum of the terms of the sequence. So both of these, if I need a sum, you need both of these. So now let's enter the formula. So parentheses, -1, close parentheses, power of x, and then 4, power of x, comma, indicate the variable, comma, the range, 1, comma, 5, parentheses, and then hit enter. And I get -820, which is this answer right here. Okay. Now, the second one there works the same. And you can do it either manually. Again, the range is not that bad. It's just from 1 to 5, so you could do it manually and then just list them and then add them. Or you could use this method here in the calculator and you would get 240. Okay, so that concludes the video. I hope this is helpful, and if it is, please subscribe, and we'll see you in the next video.